bench AC source can support a device perfectly at steady state and still shut down the moment that device is energized. Startup current, not nameplate wattage, often exposes the first sizing mistake. Capacitors charge, transformers magnetize, motors accelerate, and control electronics settle, creating short current peaks that a marginal source may interpret as a fault. Selection should therefore begin with the device under test. Define its load type, rated apparent power, startup behavior, duty cycle, and expected operating conditions before comparing equipment. Resistive loads, switch mode power supplies, chargers, transformers, motors, and control boards can place very different demands on a source, even when their nameplate ratings appear similar. Treat VA capacity as a boundary, not a target. Matching a 500 VA load to a 500 VA source leaves little room for inrush, line sag testing, measurement uncertainty, or future product variants. Meaningful headroom is important, but it must be considered alongside published overload behavior. A stated short overload capability can be valuable only when its magnitude and duration align with the actual transient. Voltage and frequency coverage come next. Products intended for multiple markets may need controlled testing at 110V and 220V class conditions, as well as 50 Hz and 60 Hz. Low line, nominal line, and high line checks can reveal dropout, heat rise, instability, and reduced design margin. Frequency adjustment can also expose changes in transformer heating, motor speed, fan noise, timing, and efficiency. For many electronics benches, selectable 0 to 150 VAC and 0 to 300 VAC ranges provide practical coverage of common mains families. A 45 to 250 Hz output range can support standard grid checks plus useful diagnostic variation. Specialized aerospace, marine, or higher frequency applications may require a different platform, so frequency range should always follow the application rather than a generic preference. Measurement visibility determines how efficiently those tests become evidence. Front panel readings for voltage, current, frequency, wattage, and power factor let engineers and operators identify abnormal behavior without assembling a separate meter chain for every routine check. Power factor is particularly useful with adapters, chargers, and electronic controls because it can reveal load behavior that voltage and current alone do not explain. These readings improve daily screening, although calibration-sensitive or formal compliance work may still require dedicated instrumentation. Protection must also be evaluated as part of the test method. Overcurrent, overtemperature, overload, and short-circuit protection can limit damage from wiring errors or unexpected faults. The important question is how the source responds, whether it alarms, limits, or shuts down, and whether that response permits realistic startup without nuisance interruptions. R&D and small batch production place different demands on the same bench. Engineering teams need flexible control, stable output, and the ability to reproduce an earlier condition during troubleshooting. Production operators need clear settings, readable measurements, capacity headroom, and repeatable procedures. Shortcut states for common mains conditions can reduce operator variation, while visible readings make abnormal units easier to identify. Bench sources from 350 VA to 1200 VA are generally relevant to low to medium power products. A 350 VA unit may suit control boards, small adapters, instruments, education benches, and service diagnostics when startup demand is modest. Ratings of 700 VA or 1200 VA become more practical for higher power adapters, multiple devices, small appliances, or prototypes with uncertain inrush. Motors, large appliances, EV-related assemblies, and more demanding stress programs may call for higher power or regenerative systems. The Matrix APS 4000 series illustrates this bench class category with 350 VA, 700 VA, and 1200 VA models, selectable 0 to 150 VAC and 0 to 300 VAC ranges, 45 to 250 Hz output, visible electrical measurements, protection functions, and published short overload information. Its suitability still depends on capacity, required frequency coverage, and whether front panel evidence is sufficient. Remote sequencing, scripted data capture, or higher power simulation may justify a more advanced programmable source. The sound buying decision combines a documented load profile, realistic startup testing, capacity margin, market-specific voltage and frequency requirements, protection behavior, and a clear plan for recording results. That combination turns an adjustable supply into a reliable validation and production tool.